In 9.2, we're going to simplify radicals. Well, what's a radical? A radical is any term that has a root symbol. Okay, and I say root because the higher up you get in math, they won't all be square roots. They'll be cube roots or fourth roots and all sorts of things. But it's anything with this little, square root looking symbol in it. Okay, that's a radical term. So whenever you hear radical, it just means the little root symbol. Now, we're going to simplify radicals. In order to simplify radicals, you must know your perfect square numbers. It's going to save a lot of time. So we're going to fill in this little chart, and I will expect you to memorize these. Okay, so if the root is 1, 1 squared, 1 times 1 is 1. The root is 2, 2 squared, 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. And those are the ones that most people know. Now from here are the ones that are a little more higher up, and I will expect you to know these. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. If you look at these two, the 6 and the 9 are just switched. So that's helpful to remember those two because they're the same numbers, just different orders. 15 squared is 225. And 20 squared is 400. We're going to use these numbers. You'll see these purple numbers a lot. Okay, so you're going to want to recognize the purple numbers. Okay, so when you see them, it'll help you know immediately, oh, wait, that's a perfect square. Let me break it down. Okay, so pause the video and fill in that table before moving on to trying some examples. All right, so how do we use these to break down radicals? Well, if I want to simplify 4 square roots of 27, 27 is not a number that was on that chart that we just looked at. So I need to try to break down 27. So first, I'm always going to try dividing by 2, 3, and then 5. The smaller the number you divide by, the bigger the answer will be, and you want to try to find the biggest perfect square when you divide. So 27 divided by 2 is not going to work, but 27 divided by 3 is 9, and that is a perfect square. So what I'm going to do is I'm going to keep that 4 that was in front. I don't do anything with that, but I'm going to take 27 and write it as 2 separate radicals. 27 was 9 times 3. And I write the perfect square radical first, because the perfect square radical, that 9, is going to become a regular 3. Square root of 9 is 3. Now I don't do the plus or minus here when we're just simplifying. If we're simplifying, don't do the plus minus. The plus minus is when we get into equations. And then I'm just going to bring this square root of 3 down. Now the 4 and the 3 on the outside, I can multiply those together, and I get 12 square roots of 3. And that is 4 square roots of 27 simplified down. So that's if you just have one radical term. In the next part, well, pause the video and fill those in if you need before moving on. So that first example is when you had one radical in your problem. Now what happens if I have more than one radical in my problem? So you see these next two examples. I have square root of 3 and square root of 12. I have 2 radical symbols. Square root of 50, square root of 8, 2 symbols. So what you should try to do first is to multiply or divide the two numbers and write under one radical. So 3 times 12 is 36. So I'll write this as the square root of 36. Now I'm going to simplify my new radical. And 36, well, that's nice because that's a perfect square. So I'll say 6. 50 and 8, okay, can write it as 1, 50 over 8, leave it as a fraction. But I should try to reduce that because 50 and 8 are not perfect squares, but they are both even. So if I divide them both by 2, I get 25 over 4. Well, that's much better to look at because those are perfect squares. So now you just square root each number and you get 5 over 2. Okay, so when you have more than one radical, try combining your two radicals by multiplying or dividing, and then square root or simplify what's left. And that's 9 too.